All right, as promised, guys, let me do a couple of these for you. I believe everyone was done with probably up to like 31. So feel free, guys. I'm going to do 31 through 63. Just fast forward to what you need for this. So for this one, it says write an equation for a circle with endpoints of diameter at these 2 points, right? So in order for me to figure out the equation for a circle, what I need is I need the center. I need to know where the center is, and then I need to know what the radius is. Okay, so if I have a diameter, right, here's a circle, here's a diameter. If I know this point and I know this point, the center of the circle is just going to be halfway. This is why we reviewed midpoint formula. So to find my center, I'm going to add my x's together, 4 plus negative 2 over 2, divided by 2. Add the y's, negative 2 plus negative 6 over 2. So when I do that, I get 4 plus negative 2 is 2 over 2, which is 1. Negative 2 minus 6 is negative 8 over 2, which is negative 4. So my center is at 1 comma negative 4. So right now I can start my equation, right? So x minus 1 squared, right, plus y plus 4 squared is equal to the radius squared. Okay, so this is the part that I still need to do. I need to find my radius. Well, the radius is the distance from the center to either point. So I'm going to use my distance formula, and I'm going to use my center point, 1, negative 4, and then I'll use this point, 4, negative 2. Okay, so the changes in the x squared, so let's do 4 minus 1 squared, plus the changes in the y. So that'll be negative 2 minus negative 4, minus negative 4 squared, okay, is equal to, so this comes out to the square root of 3 squared, and then negative 2 minus negative 4 is plus 2. 2 squared is 4. Okay, so 2 squared will right here. So this is the square root of 13. Okay, so remember that in the equation for a circle, this becomes like we have x squared plus y squared is equal to r squared, right? So we just found r. If we square r, think about it. The square root of 13 squared cancels these, right? So r squared is the equivalent of 13. Okay, so that's how you would do 31 and the problems like that. On 33, they want you guys to identify the center, identify the radius, and then graph it. Okay, so for this one, we have x minus 3, so I know that my center is at 3 for the x, and then the y value would be negative 1, because that's what makes it go to 0. So there's my center. So at 3, negative 1, I'm going to put a dot. Okay, my radius in this case is, well, radius squared is equal to 25. So radius is equal to, if you take the square root of both sides, 5. Okay, so from here I'm going to go in every direction 5. So that's here, that's here, and then here, and it's kind of on the edge over here because this thing's in the way. Let's see if I can move this. The other one would be, sorry guys, here you go, at this point. I'm going by 2, so it's throwing me off. Okay, so I get a circle that looks like that guy. So that's 33. Going on to 43. So 43, for this one, they want to know all this information, the center, the foci, the length of the major, the length of the minor, from this equation. So what I have to do is put this thing in standard form. Okay, so to put this in standard form, I'm going to get my x's together. So 9x squared minus 18x plus something plus 25y squared plus 50y plus something, because I'm going to be completing the square, is equal to 191. I just moved it over. Okay, to complete the square, I gotta have a 1 out in front of the x squared term. So in this case, I'm gonna take a 9 out, and I'm left with x squared minus 2x, and it'll be plus half of negative 2, which is negative 1 squared, which is 1. Okay, and then this guy, I'm going to take a 25 out, and I'm left with y squared plus 2y. Half of 2 is 1, 1 squared is 1. Okay, is equal to 191. Now be careful. We didn't add in a 1 and a 1. We added in 9 times 1. So we have to, since we added a 9 in on that side of the equation, we have to add the 9 on this side of the equation, because we're balancing. Sometimes earlier we were subtracting it, right? And that was because it was on the same side of the equation. Now we're on the other side, so we're adding it to both sides. Okay, so then this would also be plus 25. So when we do that math there, you should get 225 is equal to, and then let's factor this, 9 times x minus 1 squared plus 25 times y plus 1 squared. Divide everything by 225 because we are talking about an ellipse here, so it has to be equal to 1 in standard form. Okay, so I'm dividing by 225 because I'm trying to get a 1 here. So my final answer, I will move up here, is going to be 9 goes into 225. Let me see here. I guess I should do that out. I could make you guys do it, I guess. Anyway, simplify the fraction. I think you get x minus 1 squared, and then 225 divided by 9 is 25. Okay, so I just simplified the fraction, right? 9 over 225 is equal to 1 over 25, and so that's why that does that. And then the other one, 25 goes into 225 5 times, I believe. So 225 divided by 25 is equal, sorry, to 9 times. And this would be y plus 1 squared is equal to 1. Okay, so my center now. Now that I have this guy, it's nice and easy. Center is at 1 comma negative 1. The foci, to find the foci, that's the c value. So we know a squared is 25, b squared is 9, right? So c squared, which is the foci, c is the foci, is equal to a squared, 25, minus b squared, 9. That comes out to 16. So c is equal to plus or minus 4. Okay, so that just means on either side we're going to add 4, we're going to subtract 4 from the center. All right, so the center here, let's just get a visual going, is at 1, negative 1. My foci have to be a distance of 4, right? So 1, 2, 3, 4 right there, and 1, 2, 3, 4 right there. Okay, so the points for the foci are going to be negative 3, negative 1, and 5, negative 1. Okay, because that c value is just a distance from center. All right, the length of the major axis, okay, the major axis in this case is in the x-axis. That is, well, we know that a squared is equal to 25, so a is equal to 5. That's the distance from center. So the length of the total axis is just 2 of those. So 5 times 2 equals 10. Okay, and then the length of the minor would be, well, b squared is equal to 9, so b is equal to 3. 2 times 3 equals 6. So the minor is 6. So that means I could draw a picture of this thing. I can go 3 in this direction, 3 in this direction to get my minor. So that's a total of 6 spaces. Then I can go 5 in this direction, 5 in this direction to get my major. And then there is my ellipse looking something like that. Okay, so that's number 43. And then the last one I want to do with you guys is this guy, solving the system here. So when I see this kind of thing where there's a squared term in here, and I see like something nice that lines up like here, like this is, I am going to use elimination. You could use substitution here, but I'm going to use elimination. So to eliminate here, I'm just going to subtract these two from each other. Okay, this stuff goes away. Then I have x squared minus 4x is equal to 4x minus 16. I can't combine these terms, so I just have to keep them as a separate, like a subtraction problem. Okay, now I can combine like terms and solve the quadratic, so I'm going to do that. So I'm going to subtract 4x from both sides, and I'm going to add 16 to both sides. And when I do that, I get x squared minus 8x plus 16 is equal to 0. Okay, this thing is a perfect square trinomial. Hopefully you can identify that. If you can't, you know, the two things that multiply to give you 16, add to give you negative 8 would be the same thing twice, right? X minus 4, x minus 4. So my x answer is just simply 4. So I'm going to take that, I'm going to plug that back in. Right, so I have y plus 4 times 4 equals 16. Therefore, y is equal to, I'm going to subtract 16 from both sides, 0. So my solution to this system is 4, 0. And remember that this is a coordinate, and there are oftentimes going to be, like on your test, there could be no solution if they don't cross at all. There could be 1, there could be 2. If there's 2 quadratics, there could be 3 or 4 solutions, so just be prepared for that. But this one was a line, this is linear, and this is a quadratic. So the most that we could have for solutions in this case would be 2, because a line can only cross a quadratic in 2 places. But this particular one just crossed in 1 place. All right, so that is the last part of the review for you guys. If you have any questions, reach out to me this weekend. Have a good one. See you guys next time.